Types of DC generators. DC generators are classified based on their types of field connections. Separately excited generator. In separately excited generators, field excitation is provided by a controllable external voltage source. Self-excited generator. In this type of generators, field excitation is provided by the voltage output from its own armature. Initially, the voltage is built by residual magnetism retained in the field poles. Self-excited generators can be classified further as shunt, series, and compound generators. Self-excited shunt generator. In shunt generators, the field winding is connected in parallel with armature winding. Series generator. In a series generator, the field winding is connected in series with the armature winding. Compound generator. In compound generators, field excitation is given by a combination of shunt and series field windings. Compound generators are further classified into long shunt and short shunt. Long shunt compound generator. In long shunt compound generators, the shunt field is connected after the series field to the armature. Cumulative long shunt DC generator. In cumulative long shunt compound generators, the magnetism forces of the shunt and the series fields are cumulative, that is, they both create flux in the air gap in the same direction. Differential long shunt compound generator. In differential compound generators, if the magnetism forces of the shunt and the series fields oppose each others, then the machine is said to be differentially compound wound generator. Short shunt compound generator. In short shunt compound generators, the shunt field is connected directly across the armature. Cumulative short shunt compound generator. In cumulative short shunt compound generators, the magnetism forces of the shunt and the series fields are cumulative. In other words, they both create flux in the air gap in the same direction. Differential short shunt compound generator. In differential short shunt compound generators, the magnetism forces of the shunt and the series fields oppose each other. You can see the currents flowing in the shunt and the series fields oppose each other.
Yeah.